So we're now into chapter 7 of our pre-algebra textbook called Ratios, Rates, and Proportional Reasoning. So we're going to start with section 7.1 which deals with ratios and rates. So first off, what is a ratio? A ratio is just a comparison between two quantities where the quantities are measured in the same units. All right. So we see ratios arise quite a bit in an everyday basis. One of them is with sports, right? We have win-loss records. That's actually the form of a ratio, right? So like for instance, the Lakers win to loss ratio is 17 to 3 because they've won 17 games, lost 3 games. The Nuggets win to loss ratio is 13 to 4 because they've won 13 games, lost 4 games, so on and so forth, right? Now another place where ratios arise quite often is in baking, okay? And I actually found this nice little website, 11 baking ratios every pro should memorize. And it talks about why ratios matter, right? So there are certain ratios apparently in baking that work, right? Regardless of the size that you're going to make, right? Whether you're going to make a large amount of something or a smaller amount of something. So the first one here they talk about is for pound cake, the ratio is 1 part flour to 1 part egg to 1 part fat to 1 part sugar, right? So you put flour, egg, fat, and sugar in the same quantities when you're making pound cake. Another one is for pancakes, 2 parts flour to 2 parts liquid to 1 part egg to a half part fat, right? So you put double the amount of flour as eggs, double the amount of liquid as eggs, and then half the amount of fat as eggs. So if you think of eggs as the one, then liquid is double, flour is double, and fat like butter or oil or something like that is half. So it's interesting. Ratios come up quite a bit in everyday life. Okay, so first thing is the 3 different notations for ratios. So you can use 3 different notations to express ratios. One of them is going to just be simply writing the numbers out with the word 2 between them. Another one is going to be put a colon between them. And then the third way, which is probably the most useful for our purposes in this class, is going to be to write it as a fraction. So in this instance, I was talking about a group of adults, 35 of them, 15 of them are men. So the ratio of men to women was 15 to 20, right? Because there were 15 men and there were 20 women. And again, the order is important here, right? So if I had said the ratio of women to men, that wouldn't have been 15 to 20. That would have actually been 20 to 15 because I'd mentioned women first in that case, all right? So the order is important when you're expressing ratios. So a quick example of that is going to be, all right, so let's say there's 16 ducks and 9 geese in a park. What's the ratio of ducks to geese, right? So since I'm saying the ducks first, there's 16 ducks, the geese second, there's 9 geese. So the ratio here is going to be 16 to 9. Or you could write it as 16 colon 9, or you could write it as a fraction 16 over 9. And then if you're going to express the ratio of geese to ducks, you just reverse it, right? Because here I'm saying geese first, so there were 9 geese, and ducks second, there were 16 ducks. So this is going to be 9 to 16, 9 colon 16, or 9 over 16, right? So again, the order is very important when you're expressing ratios, all right? So just real quick here, with that example with the 15 men and 20 women, we had expressed that ratio as 15 to 20, right, in fraction form. But we know that 15 twentieths, if we think of it as a fraction, actually simplifies to 3/4. So that actually means that you could have expressed that 15 to 20 ratio as 3 to 4, 3 colon 4, or 3 over 4. And again, the distinction between a fraction and a ratio is if I'm thinking of this as a fraction, I'm going to say 3/4. If I'm thinking of it as a ratio, I'm going to say 3/4, right? So it's just really the context that you're dealing with, right? How you're going to say it. So again, this points out something important about ratios. The numbers used might not be the absolute references, right? Meaning 3 to 4 wasn't actually the amount of men and women, it was the simplified ratio, right? So that simplified ratio just tells us that for every 3 men, there are 4 women. And then one other important thing that comes out of this is in any representative set, then, if we're dealing with this ratio of 3 to 4, in any representative set of the total number of people, right? So if there's 3 men to 4 women, that means there's 7 people altogether, right? So in any representative set of 7 people, 3 are men. So in other words, the men are actually going to make up 3/7 of the people in the group. And you might need to do that in a lot of ratio problems, add up the two parts of the ratio to get like the total. So in this case, I added the 3 men and the 4 women together to get the 7 total, right? And that comes into play in this problem here with the passing and failing grades, right? So if the ratio of pass to fail is 7 to 5, how many of the 36 students failed the course, right? So this is actually total, right? So if I know the ratio of pass to fail is 7 pass to 5 fail, what is actually the ratio of fail to the total, right? Well, I know that 5 failed, so that's going to stay the same. But what's the total number of students here, right? Well, if 7 passed and 5 failed, that would mean that the total is actually going to be 12. So 7 pass to 5 fail equates to 5 fail to 12 total, right? And now I want to know how many failed out of the total number of students, which in this case is 36. And in the next section, we'll solve this kind of problems by cross multiplying. We'll think of these as proportions, but at this point, you can just think of these as equivalent fractions. So how did I get from 12 to 36? All right, well, I multiplied by 3. So I do the same thing here, multiply by 3. So then 5 failed times 3 is going to mean that 15 failed, right? So 15 out of the 36 failed. And then you can do the same thing with this duck and geese problem, right? So if the ratio of ducks to geese was 16 to 9, how many of the 300, and again, this is now a total birds, are geese? So if we know the ratio of ducks to geese is 16 to 9, so that means 16 ducks for 9 geese. We want the geese to the total bird ratio. So there was 9 geese again, so this is going to stay 9. But what's the total? Well, if there was 16 ducks and 9 geese, the total was actually 25. And now I want this out of the 300 total birds that I have. So how many of them are going to be geese? Well, I do the same thing I just did before. So to get from 25 to 300, I actually multiplied this by 12. So then I multiply 9 by 12, and I'm going to get my 108 geese. So yeah, important thing to remember when you're doing ratios is a lot of times you might have to add up the two parts of the ratio to get like the total, right? So in this case, 16 plus 9 gave me the 25 total birds.